What's happening, everybody? Man, guys, I'm going to tell you, we need to get some haircuts. I'm having a bad hair day, so sorry, I'm wearing a hat today. How are y'all doing? We going to cut some dovetails today? That's good. All right. Sorry, I'm running a little bit late. Well, actually, I'm actually on time. I'm 15 seconds early, but I thought I was going to run late. Running behind. So, let's see who all's here today. Hello, Kevin, Jim, and Jeff, Troy, Charles, Troy, Chuck. How y'all doing? Let's see here. Steven, Camaro, what's up, bud? Troy, Dave, George. Got the whole kit and caboodle here. Hey, Roger. All right, listen, tonight we are going to cut some dovetails based on Tuesday night's class. The little dovetail box, I'm making a little dovetail box, a little jewelry box. And we are in the, let me get everything open here. Why am I sitting here just not paying attention? I had to restart my computer and closed everything down. Stand by a second. If you weren't with us Tuesday night, we created some dovetails in the Aspire software. We talked about the Aspire software a little bit. We created dovetails, and the files could be created in Desktop, Pro, or Aspire. The only reason I created them in Aspire is because that happened to be the project I designed them in and had all my templates and stuff in that I was working with. I'm going to make that file available to you guys. I did not make it available yet. I apologize for that. I really it just got behind and everything, and I didn't get a chance to get it made. But let's see if I can get it up on the screen here. And in the software last week on Tuesday, I walked you through the layout of the tailboard and pin boards, as well as creating the toolpath vectors. And then we ended up creating the toolpaths for those vectors and everything to be able to cut these dovetails tonight. Now, this is just a very simple box. There's nothing fancy about it. I think the lid's going to be the most fancy thing about it. And when I do the 3D carving and stuff on it, it is going to have dovetail joinery for the, let me learn how to get my software going here. What's up? It is going to have dovetail joinery on the actual box carcass and everything. But after I cut the dovetails and all, I've still got to cut the pieces on the inside. The rabbets and grooves, dados and grooves for the little cross pieces and the base, the bottom of the box. So the project files, that's what I'm trying to get. See, it's been, I got rattled when my computer crashed. I was all rattled. I was nice and calm until then. The computer files, the Vectric files, I'm going to make the DXF files available for those of you that do not have Aspire, so that you can import them in and play around with them based on the video that we did on Tuesday night. And I will put them in what video description? Part 1. The part 1 of this dovetail box. I'll put the link in the description. They'll be tonight, sometime after the broadcast. I'll put them in there. You can look for them then. So if you've been looking for them and wondering where the heck they are, that's my bad. I dropped it. I dropped the ball on that one. Thanks, Troy. I'm glad you like my hat, buddy. Yeah, Jeff, I'm going to be explaining the jig that I have. Let's take a look at that camera. Let's see if we can switch over to that camera. Oh, please work for me. There we go. This is the Digital Wood Carver 2440 CNC, and on the end of the table here, I have the Dovetail jig. If you tuned into the Digital Wood Carver channel last night on YouTube, when Burl and I were talking about the joint maker jig, this is the DWC joint maker jig. This is the standard version, not the max version. It has a 10-inch cut capacity on it, and the current setup right now I have in the jig is a test board. I always run test pieces when I'm carving, just to see how things turn out and everything. And of course, I've got the tail board done, but I ran out of time for the pin board. So I'm going to take it on faith, and I'm not going to run a test on the pin board. We're actually going to start carving the pieces that we have. So you're going to see a up close setup and everything and what's going on. Let me switch over to my headphones, and I'll adjust the camera, and then we will talk about the jig that I'm going to be using tonight. Okay, real quick before we get started, let's do a little bit of an audio test. Can you guys and girls hear me on this headset? Because like I said, I got a little flustered when my computer crashed. So let's make sure that everyone can hear me. So check 1, 2. Can you hear me? All right, excellent. Okay, so let's get set up over here, and I'm just going to back the camera up a little bit and kind of pan down. My fence is a little crooked. I got it clamped on there crooked and everything. But let me bear with me a second. Let me get my software open so I can move the machine around. Did you hear that stutter? I stuttered. All right, we're going to get started here, guys. Sorry, it's a little bit of a rough start tonight, and that's on me. I crashed the system before I... All right. Let me move this back out of the way. Sorry, that I wasn't blowing y'all a kiss or anything. That was blowing dust off the table. All right, so this is the joint making jig. The jig is made up of 1/2-inch HDPE polyethylene. We've got some 80/20 tracks on the side, the front faceplate also, and the 2 side fences. This fence is adjustable, and if you'll notice here, I've got this fence currently offset from this fence, so my dovetail bit, when it cuts, will be able to clear this fence and everything. On the faceplate here, I've just got this simple clamp holding the piece in place. The clamp will loosen up and drop down so I can grab the piece out. This is the dovetails that I just cut and everything on the pin board. But this is the joint making jig, and my shop's a mess right now, so excuse the floor. But when we're doing half blind dovetails, we cut on the horizontal and the vertical at the same time, and one day we'll talk about that setup. Currently, I'm just doing working on the horizontal with the tail and pin board. The joint maker jig on my table is connected to my waste board. If any of you watched the video on a versatile waste board, this is the waste board of my table. And the front part secures to 2 threaded inserts that are in the front part of this first slat. And these back bolts go into this back T-slot. When you don't have a waste board on the table, it is designed to work to slide right into the actual table's integrated T-tracks and everything. So what I'm going to do now is I'm going to set up my actual tail board that I'm going to be cutting. And I'm just cutting some cherry. This is 4 inches by 10 inches, and it's 5/8 of an inch thick material. That's what I'm going to make my box out of. So let's go ahead and get that into place. Now, I'm going to make sure that my piece is nice and square up to my fence. And to make sure that my fences were squared to my machine, I used a simple alignment pin. Let me see if I can find that bad boy. Where's my alignment pin? Okay, oh, here it is. It's evading me. Now, for those of you that get the digital wood carvers with your Hitachi router, the basic default router, you'll see one of these things in the box and wonder, what in the heck is that for? Now, this is not designed as an alignment pin for, the CNC. It's actually designed when you're putting different bases on a handheld router. It's got a 1/2 inch diameter shank on one side and a 1/4 inch diameter shank on the other. So I simply use this as an alignment pin. I put it in my router and I run it along my fence to make sure that my fence is running true to the CNC machine. And then from there, I adjust this fence and make sure that it is square. Oops, it would help if I turn it around. Make sure that it is square to the top part of that jig, which I am, and everything. So it's all about the setup and making sure that everything, gets right. Now, I happen to have this lower fence down here. Set at 10 inches so I could just set the board right down on it and slide it over where I need it. Now, that particular setting, let's come over here from the top. That particular setting is at least the thickness of my horizontal board plus some extra. Because if you remember, I like to cut my parts proud. I want them somewhat proud when I'm assembling them, and then I will sand them flush. So I've got just very simply a 1/2 inch scrap piece of material. I lay this horizontal board on here, my piece, and I just took this 1/2 inch piece and made sure that I was flush to the top there. And that's going to give me plenty of room for when I'm making cuts that I won't hit this fence here. This fence here, because of the offset, I've got this fence offset to the side. My bit will come right beside it and clear it. And that is key. It's very important that you pay attention to your setup. That's why we do test cuts and everything. I usually don't do test cuts on good wood, but I happen to have some scrap piece of cherry from the same stock that I'm working with, same thickness, same size and everything. So it was ideal for me to test the dovetails on. All right, so now that I have this in place, I'm simply going to slide the clamp into place and lock it down. And that's it. Once I'm locked down, I'm ready to zero out and cut and everything. Now, the drilling operation and the pocketing operation, I'm going to be using a 1/4 inch upcut spiral bit. And at first I was just going to use a straight bit, but one of the things that you have to be mindful of
on a straight bit is that the flutes, the cutters, do not wrap around to the tip. And it's a little blurry, but they don't wrap around to the tip. And so therefore it's not really technically a plunging bit. It's more of a ramping bit and everything. On the spiral bit, the cutters wrap to the bottom side as well, so it can be plunged. And that's what we're going to be using. For the actual dovetail bit, let me bring my unit forward. And let me get back into position here. For the dovetail bit, I'm simply using the Fruid. Sorry about the lighting. It's not very bright and everything. But I'm using the Fruid 17/32 dovetail cutter. Now, the dovetail cutter happens to be in the router right now because I was doing that test cut. We're going to change out to the upcut spiral bit, and we're going to get going. So let me switch back over to the front camera here for a second. And let me see if I can answer some questions or something, because I see a lot of either y'all are having a conversation by yourself or you're asking me questions. Check. Can everybody hear me? Okay. Hopefully you did, or else I just said all of that for nothing. All right, let's see here. How did you mount the jig to the spoil board? As I said, on the spoil board, on the front slat, I have two threaded inserts, brass threaded inserts in the front slat of the spoil board that my front bolts that would normally slide into the table's T-tracks. I have bolts that just go straight down into those threaded inserts. The second slat back, the T-track that the slat makes, my back bolts slide into that to secure it down and everything. And so that's Tom Strickler. That's how I mounted that to the board. Laney, can you clamp both boards together, one on top and one on the machine, and do two at a time? Horizontal and vertical, yes, you would clamp them together and do them two at a time. If I was doing a half blind dovetail, that's how I would do it. You would do the horizontal and vertical. The vertical would be offset from the horizontal by however far you want. One, it'd be offset by one of the tails and the distance of one of the tails, and you would actually carve both of them at the same time. I'm doing through dovetails, so we're working just on the vertical, Kevin Wilkerson. So I can assume that once you learn how to create the toolpath layouts, you don't have to do all the drawing that you did on the joints. It looks like you just need to decide how. Well, let's look back at our software here. And basically, the only thing that you have to do on the layout is based on the diameter and profile of your bits that you're using. I'm using a 1/4 inch diameter end mill for my drilling and clearance, and I'm using a dovetail 7-degree dovetail bit with a 17/32 cutting diameter. And once I draw out those profiles, I can then lay out the profiles as I would need. And Jeff, if you were in Tuesday night's class, we spent 3 hours walking through this, and it's fully detailed. I wanted my tails equal distance from one another. And on my part, I wanted to start with half a bit diameter And then I wanted to go equal distance, and so each side was half the diameter of that 17/32. So I did half a pin, if you will, and half a tail, whatever you want to call it, and half a tail. And then I spaced them out equal distance. Once you have the layout done, because I could have done, 3 dovetails across here and one big wide one in the middle or something. You can lay them out however you want. You just got to make sure your cutter can, fit, to cut them out and everything. But once you have them laid out, then you're going to trace around this edge to create the pin board. And again, we went into full detail on that also. And then from there, we can lay out the drilling operations, which are the holes that you see here, these circles, not the holes. That's going to do some drilling operations. There's going to be some pocket cuts. That's the rectangle here. And then there's going to be some through cuts for the dovetail cutter as well as the end mill on the tail board. On the pin board, it's simply going to be drilling operations and then a pocket cut to clear out for those pins. And once all that's done, the board is laid out basically as it clamps in the software. In the Vectric software, the width of your screen left to right represents the x-axis, and the height of your screen represents the y-axis. Well, along my x-axis at the front of my table, my joint maker jig is mounted. So my material, which is 5/8 inch wide by 4 inches, 5/8 inches thick, sorry, by 4 inches wide, my material is going to be up against that joint maker jig. So it's orientated in this vertical layout. Let me turn off these toolpaths for a minute. And then the toolpaths that we created, or the layouts we created for the toolpaths here, we simply transferred over to here. So this is the pin board. And if I turn off that layer and turn on the vectors for the tail board, that is the vectors and everything. Okay. Now, let's get back to little old me. How y'all doing? Jeff, how many pins and tails you need based upon your material, your width of material? Well, you can do, I could do a single pin dovetail, big wide dovetail, single pin on a board. I could do 3, 4, 5. It just depends on the cutter that I'm using and the width of my material and how I want to lay them out. And down the road, we'll get into laying out dovetails differently than just equal distance. We'll show how to make one big dovetail and do something a little decorative with a box to get that understanding for you guys, so you'll know how that works and everything. Let's see here. Did you center the bit, or do you go to the corner start? You always start from the bottom left corner with the joint maker jig. You don't start from the center. You start from the bottom left corner. So my machine is zeroed out on the outside front corner. And let me switch cameras here. My machine is zeroed out on the outside front corner here. So if I get back into my software, let me raise my router up. I can bring it back home. Okay. And so I zeroed out, it's back there right now. It's not where it's supposed to be because I got to reset my X and Y zero. So you'll see how that setup goes. And the sad part about it is on my controller, I zeroed it out while I was talking to you guys. My hand hit the 0 button on the controller and zeroed it out back where the router was sitting. So we're going to redo that, which you'll get to see anyway. I want to show you guys how to set up your boards and stuff. All right, let's see here. Wow, a lot of Michigan fans here. Yep. Will you use the V-bit to set up your start point? I will generally put a V-bit in to find my corner, or sometimes I will use my edge finding PWC quick set block. But for me, it's just quick and easy to stick a V-bit in there and get that point right on the corner. And then once I zero it out, it's all set from there. Now I had this all zeroed out, but like I said, when I was showing the joint maker jig, I had my hand on the controller button and I zeroed it out. I've got where's my controller? I've got a very simple game controller here, and each of these buttons do something, and this button right here zeroes out the machine, and these buttons on the front zero out the X, Y, and Z independently, and this button here brings my machine back home. So I have just a simple game controller that operates my machine, and I hit the 0 button when the router was sitting back where it is. So we're going to re-zero out, and I will use a V-bit to do that. Let's see here. Can you do it just by cutting the vectors? You can do it just by cutting the vectors. Crystal, elaborate on that a little bit. You might be answering someone else's question, but you can do it just by cutting the vectors. Let me know what that means. All right, let's get back over to the machine. We're talking too much here. Let's get back to the machine and let's get things set up, and let's get to cutting, and we'll go from there. All right, let me switch back to the front cam. I wish I had, I have an HDMI switcher with a remote where I could switch from one cam to another, but only one of my cameras is HDMI, so it's ineffective, right? I got to actually manually do it. This is why I need a camera operator or a computer operator to run my camera setups and everything. All right, let's get back going here. Now, if you guys and girls, while I'm setting up and everything, or you're asking any questions, I cannot see the computer at the moment. So just bear with me, and I'll come back and check your questions and everything. I promise I will. All right. So let me go ahead and get set up and change the bit, and I am going to put the V-bit in just for the initial setup, but then my X and Y 0 will remain the same throughout the entire job. Now on the digital wood carver, the bit is changed with wrenches. It's not an automatic tool changer like some of you fancy folks out there that got those, but it's a simple 2-wrench process, and it's just like butter. All right, let's take that out. By the way, all digital wood carver owners, when you're changing your bits, well, everybody really should do this. Whether you have a spindle or a router or what have you, take your collets all the way off during your bit change. Tap out the dust and buildup, because as dust and everything builds up in these fins, it can pack in and keep that collet from gripping that bit. So you want to keep those, tapped out and clean. You don't want any buildup in those collets. Tip of the day, hot tip of the day. All right, let's see here. I wish I could get my front camera operating properly. If I could be talking to you while I'm doing this. All right, let's see here. Now, I'm not going to over tighten this. I'm just going to tighten it a little bit because I'm only using this bit just for layout purposes. Okay, just for layout purposes only. All right, sound check. Make sure y'all are still with me because I unplugged my microphone. Oh, that's fun. Somebody give me a thumbs up. Let me know that I'm still communicating with y'all. Okay, so let me see if I can turn this camera a bit. How do you like them fancy camera skills? I wish I could zoom in and zoom out. All right, so my X was the only thing that I had to reset. The Y was still set and everything. So that corner, that front outside corner is going to be my XY0. So I'm going to go ahead and zero out the X-axis and lock that in. And now we're actually going to install our cutter bit, and we're going to get to cutting. Yeehaw! All right. Grab my controller here. All right. I'm going to turn that camera. You're going to see that camera right there, that little, that's my action cam, right? Is that what we're going to call it nowadays? Action cam? That's my action cam. We're going to be moving that frequently. And kind of go from there. All right, so the V-bit comes out. My 1/4 inch upcut spiral is going in. I want about 1/8 to 1/4 of shank showing. For those of you that are new to CNC or not sure exactly how far up to put the bits on the cutter, you do not want to come up to the top of the flutes. Matter of fact, I'm sitting a little low right here. Let me get you don't want to come to the top of the flutes. I don't know how well the shading shows, but you want about an 1/8 inch or 1/4 inch of that shank showing. I usually go an 1/8. Now, the cool thing about the dovetail bit, it actually shows where the bit should be inserted to. All right, so now that I have that, I'm simply going to use my little filler gauge touch plate to touch off the Z. And the top of my material is Z0. The machine will stop automatically when it makes contact with the touch plate. And then I can zero out the Z-axis. And then put that away. Now, I don't have enough meat on that piece of wood to set my quick set zeroing block, or else I could automatically set, if I could get that to balance somehow and things, but it's not worth it. It's not worth the time and the hassle and everything. So now that everything is set, I can bring my machine back home. We're ready to cut some dovetails. All right, so the first operation is going to be the drilling and pocketing tool path. And the drilling and pocketing tool path of the 1/4 inch end mill. And before we get cranking here, let me switch back and so y'all can see my smiling face one last time. I appreciate each and every one of you. We're going to get cutting here in a minute. So while it's cutting, I may not be able to talk to you. I want to, if I'll watch the comments. If you have something to say, if it's too loud, I'm going to leave it run so you can actually hear it a little bit, but the router's kind of loud. But if it gets too loud for you, say, hey, Lainey, can you mute the mic or something? And I will. Okay. But now would be a good time probably to lower your volume just a little bit. All right. Dave Gatton. Hey, buddy. I didn't get to see you in there earlier. Okay, Mark, do you turn your router off when you change bits? Had my router start up one time while I was changing bits. No, I do not. Your software controls when that router comes on and off, unless your computer loses connection. Unless your control board loses connection, then it has no control. Some people like to turn the router off, because it makes them feel extra secure. But just don't forget to turn it back on. I can tell you how many times that I've turned the router off to use the vacuum or something and forgot to turn the router back on and went to run a job and it just buried the bit and start pushing around. I don't play that. So it stays on, and it should stay on. You should never have to turn it off. But if you had an instant mark where your router kicked on, Lord knows why, software lost connection or something, because your software is what controls it, then yeah, you might want to turn your router off until you figure out that little issue. All right, so can you pause the spindle to change bits? Sylvia, the program will stop during the bit change. It will stop after this first file is run, and when it's ready for me to change bits for the dovetail bit, which is going to be the second cutter. Once the program is finished running, and then it'll change. All right, so George, never trust electronic controls. There you go. I have the absolute faith in my machine, and no, I do not. I don't doubt it at all. But you can't. Shit happens. You can't control electronics. Things can happen, but it's 90% generally safe to operate as long as your hands are safe. But if you want to, just shut the router off. I mean, it's no big deal. Just don't forget to turn it back on. All right, let's get back to carving, or not back to carving. Let's actually start carving. The first process that's going to happen is it's going to go through and do some peck drilling. And then it's going to go clear out the pockets, but it's going to go around the entire board and peck drill and all. Now I'm going to bring my Z to 0 for a moment. And I should be kissing on the top of that board, which I am. That bit should be split, which it is. So, all right, here we go. Now I have, I'll try my best to see if you guys can hear me while it's running, but I have it taking 1/8 inch passes for the drill pecking. It's cutting down to 0.6875 inches deep, and which is going to be about, I don't know, 5 pecks. And it's going to do that on both ends and then between the fingers of this tailboard. Okay, great. Are you able to hear me clearly over the router, or should I just not talk? Now, if this was a water-cooled spindle, which one day I'll upgrade to the water-cooled spindle, I just haven't done it yet. Next time it upgrades to next time I get an opportunity, I'll upgrade to the water-cooled spindle and it'll be much quieter. I think if I'm going to be doing these in the shop videos, I may change over to the water-cooled spindle just for the purpose of being able to talk to you guys without a lot running in the background. Now I'm going to move the camera around and see if we can get kind of a side view of what's happening. So currently right now it is cutting the edges of the board. It's drilling down and kind of relieving the waste on those edges to help reduce tear out and everything. And I'm using an upcut spiral bit. The upcut spiral bit will pull those fibers up because it is on the vertical versus a downcut spiral, which would be pushing them down. And I don't want to push them down because that would cause more tear out in this vertical instance. So let's see here. You must have noise canceling because the router is actually not so noisy. Well, that's great. Evidently, these blue microphones that make me look like a pilot must have some good noise cancellation. So that's good. As long as you guys and girls can hear me clearly, that's great. Now it's working on the last space between the fingers right now. It will clear out the area. It's going to do it twice. It's going to move over slightly and do it twice. And then it'll come and do this edge that's closest to us in this view. Yeah, Troy, if I were to upgrade to the water-cooled spindle, it would definitely be a 220 water-cooled spindle. And I do have 220 in the shop here. Most of my bandsaw is 220 and another tool. Can you speed up the drill pecking operation? Yeah, I can. As a matter of fact, here, I'll speed it up. I actually have it turned down slower. So stand by and let me build it back up to its normal speed. I had it turned down for when I was running the dovetail cutter, so I forgot to turn the speed back up. You can control your speed on the fly in the Planet CNC software, and that's exactly what I did. Is I slowed down the speed for the dovetail cutter, but forgot to bring it back up to speed for the end mill. So all this is doing right now is cleaning off the edge, and you see that little onion. It's kind of just peeling it down, and on that piece is barely hanging on for a nice clean edge. Let's see if I can get up close and personal with no tear out. So it's peeling that part, that front piece down. When it's finished drilling, and I can stick my hand on that part, when it moves over, I'll show you how it just kind of brushes right off. The 220 water-cooled spindle, a 10 or 15 amp breaker. Ed. All right, let's see here. Dave, someone asked you a question if the if the router will come over the front edge of the Gatton CNC. If you happen to recall offhand. Yeah, I would recommend a 15 amp, 20 amp breaker, 15 amp breaker for your 220 water-cooled spindle. I wouldn't put a 10 amp breaker on it because the spindle pulls about 10 amp. So George has got 12.5 by his calculation, and watch those fingers. Yeah, no, it's pretty safe. I just wanted to brush away that little bit of material crystal just to show the clean cut. All right, so now it's going to start the pocketing passes. And these pocketing passes are just going to remove that inner waste material. one more pass. I have it set taking 1/8 of an inch per pass on the cuts, and it's going to do both ends first, and then it'll come back and do the other middle fingers. And I'm climb cutting on one end and conventional cutting on the other. All right. So hopefully this doesn't get too boring for you guys. This will be done here in just a moment, and we'll switch over to the dovetail bit and cut those fingers out. The dovetail bit is one pass, so it's rather quick. It'll cut those 4 fingers out in one pass. Now it's doing a pocketing operation, and you'll see that. It's going to basically come around, and it's pocketing, and those are those rectangle vectors that we saw in the software. So currently right now it's running these pocket cut vectors. Here. For this cut. All right. Got a screenshot of the controller software up while it's cutting these fingers. That is the CNC, or Planet CNC TNG motion controller software. Let me get the focus back on the camera here. There we go. A little blurry. Back up a bit and see if that clears up some. There we go. Okay, so that is the finish of that. All right. All right, let's go ahead and I'm going to change to the dovetail bit. Please release me. Now, the dovetail bit I'm using is a 1/2 inch shank bit. All right, once again, I'm going to take my little Z touch tool. Okay. And let me grab, let's see what speed I'm at here. All right. Now this is going to be a pretty fast little cut. It's not too bad. It's all one pass. So we're going to go ahead and load in. Let's so y'all can see what's happening here. Okay. All right. I'll bring the router back home. And let's give it a go. Matt, the Ed Matt, the machine stops automatically when it makes contact with the touch plate. All right. So that is it for the tail board. Now it's time to switch out and cut the pin board, or, you know, switch out to the pin board and set up for that. And that is, and we'll test our fit. Let's see here. Now that you have the bottom fence adjusted for the right height for your piece, all you should have to do is flip it to the other side and rotate and clamp it. Exactly. Yeah, I'm going to do the pin board just so you guys can see that cut and everything. But yes, all I would do is just flip the board over, clamp, cut, you know. And I would normally, while I have the end mill in, I would do all the end mill cuts. And when you flip the board, when you flip the board, you would flip it in this orientation. And then, you know, get ready for the next cut. And I would do all the end mill cuts first, flip it, do the end mill cuts on both sides, and then get all 4 of my pieces done, because I have, you know, 3 more cuts to do. I have the other side of this board, and then I've got, you know, my other piece. And so I'm gonna, I will carve those momentarily, but right now I'm going to set up for the tailboard. Now I'm not going to adjust my lower fence. I'm going to leave that for my, let me get my unit raised up and out of the way. I'm not going to raise that lower fence up that's set up for the 10-inch pieces, because I will go back and what am I trying to say, guys? I will go back and cut them after later. But I just want to do a full, let's move that out of the way. All right, let's see here. Now, once again, sorry, hold on a second. I'll use this piece here as well as my spacer piece, and all I'm going to do is just raise this up, make sure that it's flush, and then I will bring my fence up and clamp it in position. All right. So with that into position, now I'm going to change back to the end mill bit. So bear with me a second while I do that. And I don't like doing a lot of bit changes, so I would, like I said, I would cut all of my end mill cuts first, flipping that board and doing all both boards, the front and back tail board, and then do all the end mill cuts first, then do the dovetail cuts, and then I would switch to my pin board and do all of those cuts, which is basically just there's no bit change on that. It's all end mill work. All right, so let's go ahead and touch this off. I'll use this controller while it's handy. Hang tight for a second. And when it makes contact with the touch plate, whether it be this or the DWC Quickset, it stops automatically. For, I forget, I think that was Troy or some Mark or someone asked that question. All right. So with that, we can come into our software here. Now on the software, let me see real quick on my pin board drilling. I'm going to increase this cut depth and recalculate that. And the pocket's fine. I just needed to, I think the pocket's fine. Let me see here. What's my cut depth on the pocket? Yeah. Okay. Let me save these two. All right, back in our controller software, we're going to open that up. And this cut is going to do two drilling operations across the top for each of the pins. And then it's going to do 3 across the bottom for each of the pins. And then it's going to do the pocket to clear that out. All right, so let's bring our machine back home. I'm going to actually bring it to 0 just to make sure that I'm all good, which I am. And Bob's your uncle. Here we go. All right, what am I missing? Are y'all talking in there? Time for a Sprite, Laney. Yeah. My current Sprite, I dropped the can and the bottom bulged out like a bubble, so it doesn't balance very well. It's like spinning on the top. It's a gamble every time I set it on the top of the table. Rotate, not flip. Very useful. Put an X so you don't get confused. That's a good tip. So you rotate your board. You don't flip it. You rotate it. Very good. Very good. Let me see here. Troy's answering some questions. You absolutely want to rotate, not flip, because that would screw your pin board up big time. Might not be too big of a deal on the tail board, but the pin board would be for sure. But you want to rotate, not flip. Could you have run the program without running? Could you have run that program without running that first program? Could I have run the Dovetail program without running the first drilling operation? Absolutely. But I risk getting a lot of tear out and stuff that way, Dave, because it's taking a full 25-30 second pass. So these drilling operations and pocket cuts are used to relieve some of that waste material for the dovetail cutter, because the dovetail cutter is taking the full 0.6875 pass, and that's a big bite. Could risk getting out. Oh, Troy, thanks, man. Troy answered that question for Dave as well. So, all right, cool. Let's see here. Everyone knows Uncle Bob, right? No. Who's Uncle Bob? Bob's your uncle. Oh, there you go. I just said that. I'm like, wait a minute. Who's Uncle Bob? Bob. Yep, Bob's your uncle. You may have to launch that one into the back 40. Launch which one into the back 40? I'm not sure which one I got to launch in the back 40. Let me know what that means, Dean. All right, there should be a simpler way to draw those dovetails. Tom, buddy, there's probably 100 different ways to draw those dovetails, but this is the way I was taught and the way I'm teaching you. It's the one most simplified. It's the most, I can lay out a set of dovetails in 5 minutes with that method. Teaching you guys, I laid it out in 3 hours so I could instruct you on how to do it. But I can lay out dovetails very quickly with that. So, Tom, if you find a different way, share it with the group. Join the Spindle TV subscribers group on Facebook. Share that with the group. Love to see it. Make a video if you can. That would be awesome. And everything. But with that method, once you get the hang of it, you can lay it out pretty darn quick. I just took a long time teaching you guys because I wanted to show you and try to explain every single step to it. It takes full bites when you use the dovetail jig. Yeah, that's true. It takes full bites when you use the dovetail jig. Could do that. All right, so it's going to be on this back side of the board. It's doing 3 passes per, what do you call this? Pin? Per pin? That'd be, oh, yeah, the Sprite can. Yes, Dean, throw it in the back 40. No, man, that'd be waste. I got to drink it first, but it's pretty funny. Let's see here. Let me see. I wish I could do, I need to get everything set up to where I could do 2 cameras at one time. But, yeah, the bottom's blown out. So when it sets down, it's kind of, it's a gamble where it's going to balance that. All right. Well, hopefully y'all are finding something entertaining out of this, or you're getting some information. Dave, I'm sure you could take a full pass, with it and everything. But, I'm pretty conservative with the cuts then. I don't want to risk tear out too much. So, and I don't use a dovetail jig. I had a Lehigh, and I sold it on Craigslist. I hand cut the dovetails or I CNC cut them, and I love CNC cut them because it's much quicker. But if it's an heirloom piece, I'll hand cut them just to say that I hand cut them, you know, for that family member or that, you know, that special someone or something like that. But most of the time, the CNC is making them. Speaking of CNC making dovetails, let's get back over to here. Crystal, I saw a picture of your shop saver and some dovetail joints. It looked like half-line dovetails. I couldn't tell. I think so, half-line dovetails. But man, you guys were rocking out mass production on those. That's pretty cool. Very, very cool. I started out with the Harbor Freight dovetail jig. Oh my God, don't waste your money on that big old POS. But then I went to I watched, I think it was Mark Spagnolo. Who was it? The Wood Whisperer. I think it was the Wood Whisperer or whatever. Anyway, they were using their jig or talking about their dovetail jig, and holy camole, that thing's expensive. But yeah, I sold that. As soon as I cut my first dovetail on the CNC, I was like, I don't need this anymore. It was just collecting dust. I threw the Harbor Freight one away. All right. Yes, sir. Half-line dovetails. Yeah, that was awesome. That picture was pretty cool. I mean, y'all had that. Y'all were cutting out some serious joints on that. I think it was out of a full sheet or something like that, wasn't it, Crystal? It was a full sheet on that table. That was pretty cool. Now, I heard the Porter Cable joint dovetail jig, Jim. I heard that was a pretty decent one. Never seen it, but though. Probably pretty affordable, too. I like Porter Cable. They're pretty good tools. Not too bad. Oh. Now, what you're going to see me do here in about 3 seconds after this finishes is I'm going to test the fit, but I forgot to give myself an allowance. And so on the fly, we're going to go into the Aspire software and set up that allowance while it's cutting. You guys have saw the first 2 cuts here, so let's switch over really quick to the Aspire software. And I forgot to give myself an allowance cut. Let me turn that off and turn the pinboard vectors on. I forgot to give myself a slight allowance cut on the pockets. It's going to be a very tight fit right now, so I'm going to go ahead and do that allowance right now. And I'm just going to give myself a 0.02 of an inch allowance. Now, since it's already cut, I'm actually going to recalculate this, doing it in one pass to just clear out that extra 0.02 of an inch. And I'm going to save that. I know it's blurry, you guys can't see that very well. But this is going to open that pocket up just slightly. I don't want too much of an allowance, but I always start with about a 0.02, and it's a negative number. So that way, let's see here. That way it will slightly overcut that line by 0.02 of an inch. Okay, so let's get back to the camera. Let's do a test fit. I know it's not going to fit, and then we'll come back and quickly run that allowance cut because I knew I forgot to calculate something in there. Let's go ahead and I could probably beat those together. I could beat those together, but now let me see if I can get that out. But I'm going to go ahead and just cut the balance. All right, here we go. Now it shouldn't. Let me see here. Let me make sure. Oh, hold on. I'm a goofball. Give me a second, guys. Pinboard pocket, negative 2,000 allowance. That's calculated. Save the pinboard pocket. Save that. Oh, that's oh, okay, hold on. I was wondering why it said drilling. It's because I didn't rename it. Okay. All right, so let's switch back over to cut that. Why is it doing the drilling? Hold on a second. Stand by. Why is it doing the drilling? Give me a second, ladies and gents. Uh, 2,000. Let's calculate. Close. Save toolpath. Because I opened the drilling like a freaking moron. Oh my God, it's right here in oh man, I'm such a goofball. Hold on a second there, ladies and gents. I opened I just renamed it to Pocket and I opened the all right, here we go. One more time. All right, let's see here. Yes, Resorter. We could have done just the pocketing without the drilling operation, but you risk tear out. So it's all about preventing tear out and everything. So Jeff, you could have done just the pocket cut without the end cut, but as that bit is pushing through right there, when it's pushing through, you're risking pushing those fibers out and tearing out the board because I don't have any backer boards or anything on it. Operator error. Garbage in, garbage out. What's garbage in, garbage out, Warren? Go back to Dr. Pepper, Paul says. Go back to Dr. Pepper. All right. And see, you know, I don't know how well the camera shows up that close, but by doing those drilling operations and everything, it just prevents tearing out the material. That's all. That's all. Much better fit. Okay, and I have my proud, I'm proud by that slight 1/16 of an inch. Like I told you guys, I like to sand flush, but that is pretty damn nice fit and joint right there. Pretty nice. All right, let's get that unclamped off the board, off the table. And let's go over to the main camera here. Bum, 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 bum. And then I'll set up to cut the other ones later. Let me switch back to the front camera. And I'm going to take this headset off. Let me switch back to my standard mic.
Testing 1, 2. Okay. Woo! Have fun, make your ears sweat. So, let me get back here in front of this camera. Whoa, move out of the way, microphone. All right. So on the dovetails, let me square it up. Get this fitting right here. I've got them just slightly proud, so that just slightly proud. There you go. You can see that. Got a little bit of tear out right here, but other than that, there's none on the faces or anything like that. So that will sand flush, sand nicely and everything. And that's it. So of course, now, like I said, on my tailboard, I would have cut all the pockets, rotated the part, cut those pockets. And I would have done that for both tailboard pieces. Okay. And then I would have came back, switched the bit to the dovetail bit, and done the dovetails. On the pin boards, they're all pocket cuts, so I would just run them, one at a time. So that's what I'm going to do. I'm going to go back and I've got my 1/4 inch end mill in there. I'm going to go back and cut the rest, the other 3 cuts for the tailboard, this one here. And then I will run my pin boards and everything. And again, those drilling operations and things like that, they're strictly to help reduce the possibility of any tear out. If I'm pocketing just straight through, I have the possibility without a front board here. I have a possibility of it pulling those fibers out and causing chipping and things. So those pocket or those drilling operations is just strictly for the purpose of preventing tear out, so you get a nice clean joint. That if you guys are in a hurry and want to just go through it, But what I would damn sure do if I was doing that, knowing that my cutter's coming from behind forward, I would absolutely clamp a faceplate board on there to help get some stability, so it as it's coming through, that it doesn't pull those fibers with it and tear it out. So that's how I would address that. But once this gets glued and squared up and everything, it'll go well together. Let me see if I can. You don't want to take them apart and put them together too many times, but let me see if I can. So Pin board, tail board. Nice looking joint. Dovetails. All right, pins and tails, pins and tails. All right, so yeah, and it's a good looking joint. If I let me see here, and I did a good job on making sure, you know, on the fly. I forgot to pay attention to that, but I made sure that the faces match and all that stuff for the inside and the outside of my box. So that's good. So because I cut this out of one continuous board, so it's going to be like a continuous grain with a dovetail joint. But I don't want to put these back together. I don't want to stress the joint and all, but it is a nice fitting joint. I mean, I could just easily just push it back together and stuff, but I don't want to stress it out. And then cut that. Now, as far as the other rest of the box goes, this is the dovetail portion of it and everything. I think next Tuesday's class, we will import the design into Vectric and lay out the tool pass and all for the bottom cut and the dividers and all. Kind of split this up a bit. I'm not going to do a live event tomorrow like I did, we did the 3 in a row for the courage sign. This is going to be the cuts. I'm not going to do a live event tomorrow. But Tuesday we will we'll import that design, get those tool paths and everything laid out for the base of the box, because all of these parts have to get cut. There's going to be right along on the bottom side, which is the bottom, but right along the bottom on the inside, there's going to be a 3/16 inch groove all the way around for the bottom of the box. And then there's also going to be a 3/16 inch groove for the dividers to go into. So these parts are not finished yet. Once they get the dovetails on them, they still have to go on the table and get their finishing cuts and everything. But we'll lay that out Tuesday, and we'll also lay out the lid and the model that I'm going to carve onto the lid. So yeah, this one's going to be a short class tonight. Yeah, I'm gonna go cut the rest of these dovetails. I just wanted to cut that joint with you to show you how that goes, and I'm gonna set up to cut the next one. Let me see what all y'all are asking here. Let me see if there's I got this big old microphone in my way and it's hiding the chat. Hold on a second here. Yes, a backer board. Let me see here. You do have to be George. You do have to be 10% smarter than the machine. Let's see here. The laugh you not knowing. I don't know. Let's see here. Good clean cuts. Nice clean. Thanks, guys. Thanks on the fit. Love it when things fit together. You know, like moonshine in a mason jar. Love it. We fit together like moonshine in a mason jar. Oh my God. Let's see here. What's the easiest way to learn the difference between pins and tails? What is the easiest way to learn the difference between pins and tails? Now, Troy, it looks like you are asking that question because you already know the answer and you want to see if I do. What is the easiest way to learn pins and tails? Well, let me see here. This is, let me see here. All right. Dovetails, right? The shape of the tails. I don't know the answer to the pins. The pins, I just know, just trap the dovetails. I don't know. What's the easiest way there, Troy, if you know the answer, because I don't know. Were you asking the question because you didn't know the answer, or are you asking the question because you were quizzing me? I didn't know if you guys are quizzing me tonight. But what's the easiest way to know the difference between pins and tails? There probably is a way. There probably is some kind of method to know the difference between pins and tails. Tails basically look like the tails to me, and pins pin that board. They pin those tails. So it's the sockets. That's about the best answer I can give on that one. Let's see here. Could you clamp a backer board to the machine bed to run it through the other way? Yes. Could you clamp a backer board to the machine bed and run the bit through the other way? Yes. Yeah. Yeah. I could do a horizontal board and a vertical board, whether it be a waste board or whatever. I can run the bit the other direction from the outside in, and that could be my backer board. Absolutely. On the horizontal. I could clamp that, as the backer board, and I could have a waste piece back there clamped down. That's you're absolutely right. I could totally do that. Dave, great question. Could you do that? And what Dave is referring to, let's switch over to that camera just real quick. I know you guys know what Dave is referring to, but for those of you that do not know what Dave is referring to, what Dave is referring to is hope y'all can still hear me with that microphone. Could I have had a board clamped here and another board behind it to act as a sacrificial board or what have you, and run the bit forward to backwards, through here, and this be the backer board that I'm cutting into? Absolutely. And it would actually be up this high. It wouldn't be down flush. It would be up this high. And that could be my backer board for sure. Totally could do that. Totally tubular, dude. Could do it. So yeah, that's a great question, Dave. You absolutely sure could. No. You guys, Crystal, I saw your post. Hold on a second. I have a Facebook page and website, but not here to promote my business. Sorry, this is Laney's show. If Laney accepts, Laney can share. You guys, absolutely, if you want to promote it, if anybody wants to promote anything, you can promote it in the subscribers group if you want to share your stories or what have you. If you want to give a shout out to your website or whatever, go for it. I mean, absolutely. I'm all about promoting the woodworking community. Do it. So yeah, you sure can. I knew you were Southern. Yeah, moonshine in a mason jar. I'm a little Southern. Let's see here. One can be done on the straight bit and the other needs to be the dovetail bit. I was thinking this was going to be a tight fit. Richard, that might be 22115. Yeah, the tool, the dovetail tool that I'm using is the Fruid 22115. Did you see? Look! Did you see how I went back? I leaned back. That's the sign of old age, guys. Don't get old. That's like, even with glasses on, it's like, yeah, 22115. So that's the dovetail bit I'm using. It's the Fruid. It's got a 17/32 cutting diameter, 7-degree angle, and overall carbide height of 25/32, 1/2-inch shank. So. Oh, why are you not seeing the comments? Because I haven't clicked the button up. I'm being lazy tonight, Dean. I haven't clicked the button to pop them up. What Richard was asking is, what is the Fruid bit number for the dovetail bit? And after Richard asked that question, George jumped in and helped out with the answer, 22115. And Warren, thank you. That one's worth putting up on the screen. But I am an old man. The glasses make me look old, right? And the gray hair. Woo! My God. You know what? With this COVID-19, there's no haircuts or anything like that. We're going to all be looking rough. That's right. All going to be looking rough. Farm girls, it's your time to shine. Love me some country girls. All right. But yeah, no, I need a haircut. But yeah, no, I'm old, man. I need some Just for Men, get that hair color back. All right, ladies and gentlemen. Any other questions? I have a few good years left. Yeah. And for the I'm not shy about it. I am 46, six, 45 or 46, somewhere around there. I'm one of those two. But I honestly have no idea. It's one of those two. How old am I? Oh, well, not important. One of those two, 45, 46, 1974, whatever the math is. It's been a great day. Let's see here. Got beat by a long ways. 73. There you go. Yeah. So Dovetails, anyone? I'm going to finish this up. We're going to do the box on Tuesday. We're going to finish up the box design, create the tool pass for the parts that are going to get cut on the inside. We're going to do the lid and the 3D model layout for the lid of the box. And then most likely in the shop, we will cut those grooves, or I might already have them pre-cut, but we'll do the assembly of the box. Maybe. Yeah. Absolutely. But Jeff's old enough to be my daddy. Jeff, you could be my surrogate daddy. No. I was raised by a single mama. I didn't have no daddy. Hell. Anyway, listen, I want to thank you very much. I'm just rambling now. You can tell it's getting late. Hour and 33 minutes, guys. We're about to say our goodbyes. Dean says that, hey, maybe inlay the top. You know what? I haven't settled on the 3D model. I could do a V-carve inlay for any of those of you that want to learn how to do V-carve inlays. We could do that. We could do a V-carve inlay project and do it in the shop carving that V-carve inlay. Yep, that might be a good one. Great tip. Great suggestion there, Dean. All right. Let's see here. When you put the offset of the 0.02, wouldn't that double to 0.04 total clearance? No. You're talking about the how it would open up that. I'm basically opening up that space by, it wasn't 0.02, 0.002, 2,000ths of an inch, 3,000ths of an inch is a human hair, right? Between 0.003 and 0.0034 is a human hair. I was at 0.002, which is less than a human hair. So I was only slightly relieving that a little bit for a better fit. But 0.02 would be way too much of an allowance. So negative 0.002. All right. Crystal, Dean, Dave, everybody, Stephen. I like calling you Camaro, Stephen, but Stephen, Kevin, Chuck, George, Rodney, everybody. I want to thank you very much. It's been a long night. I'm going to go get some rest. Been a good, busy day. We'll see you next Tuesday, same time, same channel. 7:15 is when we're going to start Eastern time. And until next time, everybody, I'll see you soon. Hold on a second. I still got Rodney's comment up on the screen. Let me take Rodney's comment down. Negative 0.002, Rodney. All right, bud. And yeah, it probably does double it to the 0.004. Same. I got the point of your question, but the number was wrong. But it's opening that pocket up just by 20 thousandths on both sides. So technically it would be 0.004, but very small amount. All right, now wash your hands, be safe. Until next time, see you soon.